Good morning everybody. How are you all? I hope you all had breakfast and you are energetic to start today's class because you need that. Because our chapter is rotation motion. Rigid body dynamics basically means rotation motion only. In this I have combined center of mass, collision and rotation motion. Okay. So let's see. In this chapter the most important topics are center of mass, moment of inertia, torque, angular momentum, then rolling motion. Rolling means translation plus rotation. So till angular momentum we are dealing with pure rotation motion, and when it comes to rolling we are dealing with rotation plus translation. Okay. So let's start with center of mass. So center of mass is basically a very good concept, because if you want to balance something, like you will balance your pen and all, right? How do you do that? You hold at the center of mass of the pen and you are able to balance it. Okay, so how it is happening? It is that point is acting as a point that the whole mass is located. That's why you are able to hold at that point and balance the whole object. So for any object, how to find center of mass? So if you are taking like a point, 2 point objects, okay, so M1, M2, and this is the origin. Okay, so from origin this is at x1 distance, and from origin this is at x2 distance. Then no, I can do that now. Okay, sorry students, wait a second. I forgot this. Okay, so I hope the screen is visible and I am properly audible to you all. Just give me a thumbs up if it's good. Okay, so mass M1 is at x1 distance from origin, mass M2 is from x2 distance from the origin. Then somewhere in between there will be center of mass, okay, at x distance. To find that, they have used the formula x equal to m1 x1 plus m2 x2 divided by m1 plus m2. This is if the object is like objects are lined in one dimension. What if one object is at x1 y1, another object is at x2 y2? Then we have to find x center of mass and y center of mass. So nothing to do, x center of mass, this is the formula. If you want to find y center of mass, then you just replace this with m1 y1 plus m2 y2 divided by m1 plus m2. Similarly, if there is z axis also, set coordinate 2, just replace x with z, then you will get the formula for that. Is this clear for all? This is the formula to find center of mass. Okay, now if n number of objects are there, now we just started with 2, n number of objects are there, formula will be modified like this: summation of mn xn, which means for example it will be like xcm equal to m1 x1 plus m2 x2 plus m3 x3 plus etc. will go, and denominator also m1 plus m2 plus m3 plus etc. Okay, like this we have written as summation form. So xcm, ycm and zcm. Okay, this is this one, like summation means n number of particles are there, so what will be center of mass. Now instead of number of particles we are talking about a continuous body like a pen or a desk or chair. These are continuous mass distribution. In that we cannot use summation. Summation will transform into integration. Okay, so xcm will become integral of x dm divided by integral dm. Okay, it will be modified like this. Now instead of like just coordinates x, y and z, if you want to find position vector r, then summation equation it will be like RCM, position of center of mass, will be equal to m1 r1 plus m2 r2 plus etc. divided by m1 plus m2 plus etc. Okay. So instead of coordinates, if you want to find position vector, this will be the formula. So we have only one formula, we are modifying it according to our need. Integration part, if you want, it will be RCM equal to integral RDM divided by integral dm. Integral dm is nothing but total mass. So this can be written as 1 by total mass of the object integral RDM. So this is also we can use formula. Is there any doubt in this and this, integration and summation? I hope not. Okay. So this formula which you see here, it is if center of mass is given, center of mass is r, like r distance, then what is the distance of mass m from center of mass? Okay. So this r distance is from origin. Okay, it is from origin. From origin to center of mass is r. What is this distance? This is r1 and this distance is r2. This r1 and r2 is not same as this r1 and r2. It is different. This is position of m1 and m2 from origin, r1, r2. Here r1 and r2 means distance of m1 from center of mass, distance of m2 from center of mass. So r1 equal to this formula you can use, and r2 equal to this formula you can use. Distance of a mass from the center of mass. Please note down the equation. If it's done, we will go to the next slide.
Can you take one example for this?
Which one?
This application, can you take one example?
Okay. See, if it is given that mass 1, okay, m1 is located at r1 and m2 is located at r2, okay, in this case center of mass will be somewhere in the line joining m1 and m2. How to find that? If you are using this formula, okay, if you are using this formula, you will get this RCM, vector RCM. Understood? This is like just a graphical representation. The other one, it will be like this. So there are two masses, m and 4m, okay. Center of mass, let's say it is at from origin, it is at like 4 meters. Then if you want to find distance between m and center of mass, okay, this distance r1 will be equal to, using the formula, sorry, what is the formula? R1 equal to m2r divided by m1 plus m2, okay. So m2 is 4m into r1 is 4 meter divided by m1 plus m2, that will be equal to 5m. This is meter, okay, not m. So m cancel, this will be 16 by 5 meter. Is it clear now? Distance between m and center of mass will be 16 by 5 meter. See, m and 4m are two masses. and their center of mass is at 4 meter from O, origin. If you want to find distance between center of mass and M1, you have to apply the formula R1 equal to M2R, R is RCM, divided by M1 plus M2. I directly substituted the values. M2 is 4m, RCM is 4 meter, and M1 plus M2 is 5m. Then mm cancel, it will be 16 by 5 meter. So distance between center of mass and first mass will be 16 by 5 meter. Clear? Okay. Then we will move on to the next thing. So please note down these values. Like, there is no way to remember this in any other sense. You just have to by heart these values. For some common shapes, what will be center of mass? And it is easy to remember also. See, for a triangular plate it is, okay, it is two-dimensional like lamina thing. So here the center of mass will be in, if you consider y-axis, it is symmetric to y-axis, right? So it will be right in the middle compared to y-axis. Then in x-axis it is not symmetric. So for x-axis it is located at here. Okay. So xcm will be 0 and ycm is equal to this h by 3. The point is centroid of the triangle. Okay. For example, if you are taking a pencil, it is symmetric, right? If you neglect the end point, a pencil is a uniform body, it's symmetric. So its center of mass will be exactly in the middle. So if symmetry is there, we can easily find. Symmetry is there means exactly at the center will be center of mass. If you take a notebook, like it is a rectangular shape but it is symmetric, so exactly in the middle will be center of mass. If symmetry is not there only, we have to separately find it. Now if you take a complete ring, its center of mass will be exactly in the middle, right? Like it is outside the body, that is normal only, no problem. So for a ring it will be exactly in the middle. But if you take a semicircular ring and in y-axis there is symmetry, so for x it will be in the middle, 0. Sorry. So for x it will be exactly in the middle. Okay. Now if you take y-axis, in y-axis that they have derived and found that point is equal to 2r by pi. Okay. For semicircular ring, x-axis, xcm will be 0, ycm will be 2r by pi. Now another one, like if you take semicircular disc, okay, here also symmetry is there in y-axis. So xcm will be in the middle, ycm will be somewhere above, that we have found to be 4r by 3 pi. These all have been derived using integration. If you want the proof, you can check in the internet, but it has no value in our crash course or our entrance. That's why I am not going into the derivation. Okay. So semicircular disc, ycm is 4r by 3 pi, xcm is 0. Clear? Now if as a general point, remember this. Our equation is m1 x1 plus m2 x2 divided by m1 plus m2, right? RCM or XCM. Now see, if you are if you have a pen with you, put the cap on the back side and try to balance. Afterwards, then put the cap on the front side and try to balance. You will see that when the cap is on the back side, you have to place your finger near to the back, and when cap is on the front side, you have to place your finger near to the front side. Why is this? Because the center of mass will be closer to the heavier mass. Okay, where the mass is more the center of mass will be close to that. So that is just an extra point. COM will be closer to heavier mass. Okay, that is just an additional FYI. Next, for a hemispherical shell, if you are taking, again symmetry is there, so XCM is 0, YCM is R by 2. Solid hemisphere, you know the difference between hollow sphere and solid hemisphere, right? Like if you take a globe and cut it, it will be like a hemispherical shell, like inside there will be nothing. If you want solid hemisphere, let's take a like shot put ball, then cut in half, it will be like a solid hemisphere. Okay, that is the difference. And solid hemisphere, XCM again 0, YCM 3R by 8. Coming to circular cone, again hollow and solid. Hollow means inside nothing is there, solid completely filled up. So in hollow cone, again XCM is 0, it is not mentioned here. XCM is equal to 0, YCM equal to H by 3. In solid cone, XCM equal to 0, YCM equal to H by 4. If it is clear for you all, we will move to the next. Okay. Now this, like for individual shapes and bodies, whatever you saw, those values only we have to use. But the common question that will be asked is center of mass of a body if some part is cut. In that case, you can use the area formula. Okay, this is the easiest one. We know our equation is m1 x1 plus m2 x2 by m1 plus m2. It will be modified area of first mass. Like imagine this is a complete body, what will be its area? Into center of mass of first one minus area of the region that is cut into center of mass of that region divided by A1 minus A2. Is it clear? Write down. A1 is area of body before cut. R1 is center of mass of like body before cut. A2 is area of cut region. And R2 is center of mass of cut region. Okay, if you apply this formula directly, you will get the answer. There is no other complications required. Any doubt? Is it clear for all? Just give me a thumbs up. Okay. Like if I change the slide before you note the formula, no problem. I will send this today itself. Okay, the PPT. Next one, velocity and force on center of mass. Imagine there is like two masses, m and m. Both are having v velocity in the given direction. Okay, equal masses means their center of mass will be exactly in the middle. If both are moving towards each other with same velocity, the center of mass, what will be velocity of center of mass? Okay, velocity of center of mass, if you want to find, I told you we have only one formula in this chapter, just replace with things. m1 v1 plus m2 v2 divided by m1 plus m2. Instead of position x or r, we replace it with velocity. So we will get velocity of center of mass. Okay, so m1 is m, velocity v is towards positive, plus m2 is m, v is minus v divided by m1 plus m2, that is equal to 2m. Okay. So what are we getting? Velocity of center of mass is equal to 0. Both the bodies are moving, but center of mass is not moving. It will be constant there. Now, if the velocities are different, then center of mass will have, let's say, this is case 1. In case 2, velocity of m is v, this is having 2v. Okay. In this case, if you are taking velocity of center of mass, m1 v1 plus m2 v2 divided by m1 plus m2, we can see that m1 is m v minus 2mv divided by 2m. Okay. So here you will get minus mv by 2m, that is minus v by 2. This will be velocity of center of mass. Is there any doubt in this? I hope everybody understood. Similarly, acceleration also you can find. Acceleration of center of mass will be m1 acceleration of 1 plus m2 acceleration of 2 divided by m1 plus m2. Okay, once you find acceleration, you can find force, because force will be equal to, from yesterday's chapter, force equal to ma. Since center of mass acts as a point of total mass, so we will have here total mass m into ACM. That will be force on center of mass. Okay. And here what is it? m1a1, again it is force only. Okay. Then m2a2, again force only. If we are multiplying capital M on this side, capital M is nothing but m1 plus m2. So we will get FCM is equal to F1 plus F2. This is force of center of mass. All are vectors, don't get confused. Okay. So force on center of mass will be force on the individual components vector sum. Is that clear? So we discussed about position of center of mass first, then velocity of center of mass, acceleration of center of mass, and force on center of mass. If the whole concept is clear for you, we will move to the next thing. Can we? Okay. Next, going towards collision. In collision, you might have had long derivations and all for this. We don't need any of that. Okay, we need only.
Force concept repeat.
Yes.
Force.
Force.
Force का repeat करो.
Acceleration of center of mass we found, right? Now, force is equal to mass into acceleration. At center of mass, total mass is acting. Total mass is capital M, or we can say that this is m1 plus m2, capital M. Okay, that is total mass. Now, if you substitute, if you multiply m1 plus m2 on the RHS also, m1 plus m2 multiplied by m1a1 plus m2a2 divided by m1 plus m2 will come, right? So these two will get cancelled. We will remain with m1a1 plus m2a2. m1a1 is force on a1. m2a2 is force on a2. So center of mass force will be equal to individual forces on 1 plus 2, or individual forces sum, vector sum of particles. Is that clear? Dheeraj, is there any other doubt or need more clarification? Okay. In collision, we need to know only two concepts, if it is elastic or inelastic. Okay, if elastic collision, okay, conservation of momentum will also be there, and conservation of mechanical energy will also be there. Okay, conservation of momentum we discussed yesterday. You already know that before and after momentum total momentum should be same. Conservation of mechanical energy, that there we are only considering potential energy and plus kinetic energy. Okay, so before the collision and after the collision, total potential energy plus kinetic energy should be same before and after. So for elastic collision these both will apply. For inelastic collision, only momentum is conserved. Okay, in inelastic collision only momentum is conserved, like mechanical energy is not conserved. If you consider like total energy, heat, light, electricity, everything, energy is also conserved, but mechanical energy is not conserved in inelastic collision. Okay, but how to do problem with this? So you will need only one value, that is coefficient of restitution. This value is coefficient of restitution. If you know this value, you will be able to solve most of the things. Okay, so velocity of separation by velocity of approach, that is the actual definition. But if you see the formula, this is v2 minus v1, final velocity, change in final velocity by change in initial velocity. Okay, just apply here, you will get the value of E, then your solution will be easy, because from conservation of momentum we will have m1 u1 plus m2 u2 will be equal to m1 v1 plus m2 v2. Sorry. Okay, so from conservation of momentum we already have this formula, m1 v1 plus m2 v2 equal to m1 u1 plus m2 u2. Okay, is it audible and visible now? I hope in between the connection was lost. Are you able to hear me? No. How about now? Is it okay now? Are you able to hear me? Is it okay now? Yes, okay, thank you. So what I was saying is, from conservation of momentum, we already have this equation m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. Okay, along with this we are having one more equation. So as you know, we have only two unknowns, v1 and v2. These are our unknowns. We don't know what is final velocities. So if we know two equation, if we know what is E, then we can find v1 and v2, because we can substitute v2 minus v1 equal to E into u1 minus u2. Okay, with these two equation we can solve for v1 and v2. Okay, just note these down. Even if you did not note, no problem, I am sending this PPT. We will move to the next topic. Can we? Okay, now there is value of E sometimes given in the question. Sometimes they will not say what is value of E, they will give elastic collision. If it is elastic collision, E value is equal to 1. Okay, so v2 minus v1 equal to u1 minus u2. Okay, for elastic collision, value of E equal to 1. For inelastic collision, value of E will be between 0 and 1, not equal anywhere, between 0 and 1, then it is called as inelastic collision. One more case is there, that is perfectly inelastic collision. In this case, value of E will be 0, which means u2 minus u1 will v2 minus v1 will be 0. This implies v2 minus v1 equal to 0. That just means that v2 equal to v1 equal to v. Perfectly inelastic collision. So if this term comes perfectly inelastic, it means that two things hit together, after the collision they are moving together. Okay, perfectly inelastic collision means like two objects collided, after collision they are moving together, that's why they have same velocity. I hope this is clear for all. Coefficient of restitution. Okay, then we will move to the next topic, that is
Can you take example of previous one?
This one. Okay, see, there are two bodies M and 2M. Okay, initially like u2 equal to 0, imagine, and M is moving with u1 velocity. Okay, it is said that it will be a perfectly inelastic collision. Then they will collide, M and 2M. After this collision, M and 2M, okay, both will move with same velocity v. Okay, now how to find this? Our momentum equation m1 u1 plus m2 u2, that is our initial momentum. If you see that u2 is 0, so this term will become 0. m1 u1 will become m u1. Okay, now final momentum is total mass 3m in v, so final momentum is 3 mv. Initial momentum should be equal to final momentum, so we can substitute that mu1 equal to 3 mv. M cancel, we will get that final velocity equal to u1 by 3. Okay, this is one example of perfectly inelastic collision. Is that okay? Okay. Now we are comparing between linear motion and rotation motion. I think very basic of this we covered yesterday for circular motion. Like it is in like a little bit in depth. As you can see, these are our equations of motion from linear motion. We have their analog here, and how it is converted. S will be converted to theta. Initial velocity u will be converted to omega I, initial angular velocity. Final velocity we will be converted to omega f, final angular velocity. Acceleration a will be converted to alpha, angular acceleration. Okay, so first three equations I think you know, we did talked about it yesterday. This equation, this is the equation for distance covered in nth second. Okay, so from 4 to 5 how much distance is covered, that you should know from this formula. Okay, so in 5th second how much distance did it cover from 4 to 5, this formula we can use. Same way for nth second how much angle change, that is for this equation. Okay, and we know that linear velocity v equal to dx by dt. So angular velocity omega will be d theta by dt, and linear acceleration dv by dt or d square x by dt square, angular acceleration d omega by dt, d square theta by dt square. Okay, understood the similarities? And some other examples I took the other day. Linear momentum P equal to mv, mass into velocity. When you come to angular momentum L, it will become I omega. This we will see further in the class. Okay, these topics. If you understood these two comparison, then we will move to the next one. Can we? If you understood this, please give okay, thumbs up. Now coming to moment of inertia. Okay, moment of inertia is the mass analog in rotation motion. So mass is the like measure of inertia. Measure of inertia. Why do we say that? Let's say a object is at rest. You want force to move it. If it is a small object, you need less force, right? If it is a big object, you need more force. So like how much force we need to apply, that depends on mass. So inertia is the inability to change the state. So that will depend on mass of the object. Okay, that's why we say mass is the measure of inertia. Now when it comes to rotation motion, like there will be a hindrance for any object to rotate. That hindrance is called as moment of inertia. Okay, so m in linear motion will become I in rotational motion. I is moment of inertia. And what is moment of inertia? If imagine that one particle m is rotating about this axis. Okay, this particle m is rotating about this axis. It is at like r distance. Then okay, next one, sun rotates around its center once in 27 days. What will be the period of revolution of sun if it were to expand twice its size without changing the radius? Okay, so this way we have to apply conservation of angular momentum. Okay, so time period equation is 2 pi by omega. Okay, so omega change, time period will change. Initially I is the moment of inertia of sun, that we can take as 2 by 5 mr square, because we have to consider as a solid sphere of uniform density. So moment of inertia of sun is 2 by 5 mr square, and initial momentum will be I omega, that is 2 by 5 m r square omega. Now final momentum will be nu inertia into nu omega. Okay, here new moment of inertia, how it is changing, like radius is not changing, sorry, radius is becoming double, mass is not changing. Okay, so nu 1 will become 2 by 5 m r by 2 r the whole square omega dash. Okay, so this is 2 by 5 m r square omega dash into 4. So 2 by 5 m r square we can cancel on both sides. From this you will get that omega equal to 4 omega dash, or omega dash equal to omega by 4, which means new time period t dash will be 2 pi by omega dash. This will be 2 pi divided by omega into 4. So new time period will be 4 times old time period. Old time period is 27 days, into 4 you will get 108 days. This will be the answer. If this is clear, we will stop the class for now. Okay, some other questions also I have included in the PPT. Please try to solve them. Any doubt you have, please reach out to me. Okay, chemistry class will be at 12 o'clock.